this lecture, in group theory, we are going to see about matrix representation of various symmetry operations. Any symmetry operation about a symmetry element in a molecule involves the transformation of set of coordinates known as x, y, z of an atom into a new coordinates x dash, y dash and z dash. The two set of coordinates of the atom can be related by the set of equations. This set of equations may also be formulated in matrix notation. So each symmetry operation can be represented by a specific matrix. So the definition for matrix is it is a rectangular array of numbers or symbols. Here we have given the examples. The order or dimension of a matrix is defined by the number of rows and number of columns. Here we have given the example with the 3 cross 3 dimension. A special case is a square matrix in which number of rows is equal to number of columns. First, we will see about matrix for rotation operation about CN axis. Consider the vector R in two-dimensional coordinate system which will have x and y coordinates. Here we have taken the vector R. We are rotating this about an angle theta and the vector R is transformed into vector R dash. Now the Cartesian coordinate x is transformed into x dash, y is transformed into y dash. R can be represented as a column matrix R is equal to xy. It will be transformed into x dash and y dash. Now R dash can be represented as column matrix x dash and y dash. Now these two equation 1 and 2 can be related by matrix rotation equation, that is x dash is equal to x cos theta plus y sin theta, y dash is equal to minus x sin theta plus y cos theta. We can written as column matrix x dash y dash is equal to cos theta sin theta minus sin theta cos theta into xy. Here x dash and y dash is R dash vector and x and y column matrix is R vector. Using this, we can compare the above equation, that is sixth equation, with Cn, that is proper axis of symmetry with rotation about an angle theta. Then the rotation operation can be expressed as R dash is equal to Cn into R. By comparing equation 6 and 7, here Cn is equal to cos theta sin theta minus sin theta cos theta in the above equation. So we have written here Cn represents the matrix for rotation operation. If we extend this into 3 dimension, the matrix Cn which represents the rotation about z axis can be written as Cn that is equal to cos theta sin theta 0 minus sin theta cos theta 0, 0, 0, 1. If we consider the theta as equal to 180 degree by applying it in equation n is equal to 2 pi by theta, we substitute theta equal to 180 and the order becomes 2. So C2 operation can be written as C2 is equal to cos 180 degree sin 180 degree 0 minus sin 180 degree cos 180 degree 0, 0, 0, 1. Here cos 180 is minus 1 and sin 180 is 0. If we substitute the value in this matrix and we will become minus 1, 0, 0, 0 minus 1, 0, 0, 0, 1 as a matrix representation for C2. And if we consider theta equal to 120, the order will be 3. And for C3 operation, we can get the matrix representation in this form. Cos 120, sin 120, 0, minus sin 120, cos 120, 0, 0, 0, 1. Cos 120 degrees minus 1 by 2 and sin 120 degrees root 3 by 2. If we substitute this two values in this matrix, we will get minus 1 by 2, root 3 by 2, 0, minus root 3 by 2, minus 1 by 2, 0, 0, 0, 1 matrix for C3 operation. If we take theta equal to 90 degree and it will become C4 operation of rotation and C4 is equal to cos 90 degree sin 90 degree 0 minus sin 90 degree cos 90 degree 0, 0, 0, 1. And here we have given the value of thetas according to sin, cos and tan, cosec, sec and cot theta. By taking the value of cos 90 from this table 0 and sin 90 as 1, we will arrive this matrix for C4 rotation operation. Next, we will see about matrix for reflection operation. Here we are reflecting the x component along with y plane, and now consider the r vector with the components xy. By reflection across the y axis, the components x and y become x dash and y dash, and the components x dash and y dash are related by the equation x dash is equal to minus 1x plus 0y and y dash is equal to 0x plus 1y. We can combine this equation in matrix form x as a column matrix for x dash y dash is equal to minus 1 0 0 1 into xy. If we substitute the x dash and y dash as r dash and xy as r and comparing the equations, we get sigma yz plane is equal to minus 1 0 0 1. And if we extend this into 3 dimension, the matrix can be written as sigma yz is equal to minus 1 0 0 0 1 0 0 0 1. Similarly, sigma xy plane is equal to 1 0 0 0 1 0 0 0 minus 1 matrix. And for sigma zx plane, the matrix becomes 0, that is 1 0 0 0 minus 1 0 0 0 1. Now we will consider matrix for improper rotation about Sn axis. This can be arrived from the product of Cnz matrix and sigma xy matrix. Thus, the matrix S, which represents improper rotation about Z axis, can be written as S is equal to cos theta sin theta 0 minus sin theta cos theta 0 0 0 1 for Cnz matrix and 1 0 0 0 1 0 0 0 minus 1 for sigma y matrix. And multiplying this 2 will give cos theta sin theta 0 minus sin theta cos theta 0 0 0 minus 1. By applying Cn as 3, that is order 3, we will get S3 operation. For S3, the theta becomes 240 degree, and we can substitute the values and we will get the matrix as minus 0.5 minus 0.8660 0 0.866 minus 0.50 0 0 minus 1 for S3 axis of improper axis of symmetry. And consider matrix for inversion operation. The x, y, z components of a vector R are transformed into their respective negatives by the inversion operation, and we will become I dot x is equal to, that is I into x is equal to minus 1x plus 0y plus 0z. I y is equal to 0x minus 1y plus 0z. I z is equal to 0x plus 0y minus 1z. Where Ix, Iy, Iz refers to inversion operation of a components x, y and z in matrix form. These equations can be written as I of column matrix x, y, z is equal to minus 1 0 0 0 minus 1 0 0 0 minus 1 into x, y, z. By comparing this to I, that is inversion matrix, is equal to minus 1 0 0 0 minus 1 0 0 0 minus 1. Matrix for identity operation. By identity operation, the components x, y and z of vector remain unchanged. The equation which represent the effect of identity operation on the vector R given below, Ex, that is which leaves the other element unchanged, becomes Ix, that is 1x plus 0y plus 0z. Ey is equal to 0x plus 1y plus 0z. Ez is equal to 0x plus 0y plus 1z. Ex, Ey, Ez in the above equation refers to identity operation of the component x, y, z in the matrix form, and these equation become E of x, y, z as column matrix is equal to 1 0 0 0 1 0 0 0 1 into x, y, z. By comparing this, the identity matrix for identity operation is equal to 1 0 0 0 1 0 0 0 1. And the sum of diagonal elements of square matrix is called the trace or characters of the matrix. And we are adding the diagonal elements here. It becomes 3. So the character of matrix for identity element is 3. And for rotation operation, we are adding the diagonal elements here, that is cos theta plus 1, and it becomes 2 cos theta plus 1, and we have given 2 cos theta plus 1. Similarly, we are adding the diagonal element of inversion operation, that is minus 3, improper rotation, that is 2 cos theta minus 1, and reflection 1. Thank you.